Start the session. This session is going to be about the enterprise security controls for Kubernetes in the context of Calico and Calico Enterprise. My name is Ivan Sharmok. I'm a solutions architect at Tigera. Just to give you a few notes on Calico, if you don't know what it is or don't have much experience with it yet, Calico is an open source implementation of Container Network Interface, or CNI, for Kubernetes. And it's highly adopted in the Kubernetes community. It provides the CNI implementation for IP address allocation, as well as the network security on top of that. And it works for containers, virtual machines, or any host-based workloads. The Project Calico has its own Slack channel, Calico users. Currently, we have over 4,000 users, active users in there. There is over 100 contributors to the project overall, and over 1 million nodes that we know of that community shares with us. We know that run Calico Enterprise on daily basis. The Calico became popular and widely adopted because of the speed it provides. It plugs into the layer 3 network and provides encapsulated implementation as well as non-encapsulated for the best performance. And it leverages native Linux data plane, which allows it to get that blazing fast speed. It's scalable to the limits of Kubernetes. So far, as far as we tested and our customers used it, it's been running clusters on tens of thousands of nodes. It's considered to be an industry standard and was adopted by all the major cloud providers for their managed Kubernetes services, and offer it in other distributions of Kubernetes like Docker Enterprise, Rancher, OpenShift, either as an option or as a default plugin. And yeah, we know of over 150,000 clusters that run Calico today. Also, on top of open source Calico, there is a Calico Enterprise product, which builds on top of that open core concept or open core project. And you can see that on this slide, there is a range of customers from like fintech to manufacturing and large organizations that use Calico today. We also were one of the participants who launched or collabed the launch of Istio project. I think it was like maybe four years ago, maybe more. So on this slide, you can see that this slide represents the wide adoption of Calico and where you can actually use it. On the left-hand side, you can see the major cloud providers. Then there are package distribution like Mirantis, which provides Docker Enterprise, OpenShift, or just native, just upstream Kubernetes, as well as Rancher, VMware, Tanzu, and others, and all the way to the bare metal. So you can actually extend Calico or run either components of it or either target non-cluster hosts or run components of Calico on those hosts, which may not necessarily be a part of your Kubernetes cluster, and then you can apply policies on those. Now getting to security controls and to the actual main subject for this, or main theme for this talk. This is the agenda. We'll take a look briefly into Kubernetes RBAC. That will be needed for the context. I'm not going to dive too deep into the RBAC authentication authorization. That is a topic of its own. Then we'll go through the policies, Kubernetes and Calico policies. We'll implement a default deny policy, take a look into security controls that we can use, and then additional capabilities like global alerting, compliance reporting, intrusion detection, threat defense. Some of these topics will have the demo part, but some of those are still, we are still working on building demos for those. All of the materials, all of the collateral for this talk is available on GitHub. And let me actually share the link to GitHub repo. Okay. Okay, so without further ado, jumping into Kubernetes RBAC, as I said, that will be needed for the context. I will use a few objects in there and talk about some capabilities. But in a nutshell, to understand it at a high level, there are three main components to Kubernetes role-based access control. That's subject operations and resources. From subjects, we have users, groups, and service accounts. Operations, there is a list of verbs in there, which operations are allowed or can be used against resources. And resources, that's our pods, nodes, config maps, whatever Kubernetes resources. In terms of subjects, from Kubernetes standpoint, the service accounts are only subjects that are understood and managed, or not understood, but managed by Kubernetes. The user and group objects, those are not managed by Kubernetes. They are typically managed somewhere outside, like OAuth, any system that provides you management of users and groups can be used in here, and Kubernetes uses string ID to identify that object, or that object. Therefore, for this session or in the demos, I will use the service account as managed resources in Kubernetes, and to configure the necessary access. The Kubernetes network policies, they provide declarative way of defining the policy for Kubernetes workloads, for Kubernetes cluster. You can use Kubernetes API to interact with those policies, deploy, modify them, or change them. Typically, or in majority of cases, they enforced by CNI implementation. So Calico itself been a solution for the Kubernetes CNI can be deployed in two modes, with CNI, with support of CNI and network policies, or just the network policy support. That's a typical scenario for managed solutions, like for cloud providers like EKS, AKS, GKE. The Kubernetes policies are namespace scoped. What that means that you cannot deploy a policy that would be outside of the namespace, which means if you want to enforce, for instance, the typical practice or the common practice is to implement default deny policy and make sure that no one can communicate with your workloads within the namespace or within the cluster unless a explicit access is allowed. So for when using Kubernetes policies, you have to make sure that you're tracking all the namespaces in your cluster and deploying the, if you take the approach like zero trust approach to network security, then you'll have to make sure that you deploy the default deny in every namespace. The policies use labels and selectors. That's what allows the policy to be applied to a particular flow or particular pod. And there are some capabilities within the rules that allow you to fine-grain access using namespaces, IPs of the pods, and and labels in general. So, which is the requirement, because all of the workloads within Kubernetes cluster, they have ephemeral IPs, meaning that any pod, any workload that for whatever reason can be recreated will get a new IP. So you cannot really rely on the conventional methods of creating policies and controlling the traffic using IPs. Therefore, in Kubernetes, that concept has shifted to using labels, Kubernetes constructs for that. And everything you do in Kubernetes, or majority of things, that's typically using the kubectl, 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 whatever name you like for that. So some of the policies also have direction, which allows you to configure ingress and egress rules. By default, Kubernetes acts that if there is no policy applied to a specific flow, then access is allowed. As soon as you apply any policy that affects that flow, the access will be allowed only for what you specified in the policy. Everything else will be denied. So that's something to be conscious about. So to compare the Kubernetes policies to Calico policies extend the functionality, the default functionality provided by Kubernetes network policies. But on top of that, Calico network policies provide additional capabilities. The policy ordering is one of those. There is a field that allows you to specify the priority for your policy. The integration with Envoy proxy allows Calico to target L5 to L7 network rules. Calico also can protect or can target the host interfaces, which means you can protect not only workloads within your Kubernetes like pods, but you can also protect the endpoints and ports on your host for the host interfaces. And one of the capabilities that Kubernetes network policies do not have, that's the ability to deploy global scope network policies, which means that they live outside of any particular namespace and applies to the entire cluster. If you're familiar with Kubernetes RBAC, it's similar to how role differs from a cluster role, or role binding from a cluster role binding. Also, Calico network policies support explicit actions, which provides some additional functionality in there. Instead of just binary allow deny, there is also log and pass. Pass comes useful when you're working with the Calico Enterprise, where you have ability to create tiers in which you can stack your policies. And besides the endpoints and namespaces, you can also select service accounts when you're defining rules in Calico network policies. That allows you to further fine-grain the access to particular workloads within your cluster, where you can say that only specific service accounts can initiate the connection, or the connection can be allowed for those, but not if some different service account is used. If you explored the how Kubernetes uses service accounts, you would see that any namespace you create gets a default service account that is used for any workload that you're running within that namespace. And if you not explicitly specify another service account to be used. And so additional capabilities in Calico Enterprise are DNS policies, policy tiers, policy preview and staging. Those allow you to policy preview and staging allow you to have a policy lifecycle where you can preview the changes you're making to the policy before you actually enforce it. So default deny, or as typically called catch everything policy, is a common approach to securing your Kubernetes cluster, where you can create a default deny rule and then start making policies that are targeting specific flows within your cluster between the workloads that you are running. What that allows you to do is to make sure that nothing else can communicate unless that flow is established and allowed. The Calico's global network policy can be used in here, where that would span across the entire cluster, so that you don't necessarily need to create those default denies for every namespace. And then just can target with one policy, you can target everything, all of the namespaces, which in a cluster, and probably most typical scenario when you have a cluster dedicated to development activities, where developers can come in and maybe they are allowed to create their namespaces in there, or the ops team can create a namespace at any given time to issue that to a team. Then with a single policy, you can target all of the namespaces without worrying about missing the step to apply the default deny. Okay, before I jump into security controls, I want to go through a few demo scenarios just to show you how these policies work. And maybe before I do that, let's see if there are any questions. Okay, how can we secure things using Kubernetes? Not sure what you mean by things. I assume that's going to be pods and workloads running within the cluster. The network policies is the approach that allows you to create the rules for egress rules, and I will be showing that in a moment as I'm going to go through the demos. So if I don't answer that question, could you please refine it to be a little bit more specific? Is Calico built into the latest KDS packages, or is it still a module package at dawn? So Kubernetes by itself is built without being dependent on any specific implementation. It's a higher level abstraction. If you look into it, a lot of components within the platform are implemented by different vendors. Some of the components implemented straight by Kubernetes maintainers or Kubernetes community. Some of those have various implementations from proprietary vendors or other open source solutions. So in general, CNI and as pretty much most of the Kubernetes are built in a way that there would not be a dependency or on any specific implementation. So Calico being just one implementation of many. And therefore, you have to install it, but the installation within Kubernetes platform, as pretty much anything you install in there, is application of a YAML file. So you have a YAML definition that you apply, and the rest will be taken care of by the product that you're deploying. So in case of Calico operator will take care of setting up everything needed to plug in the CNI and to configure necessary components. How is it different than Azure native network policy? So Azure native network policies, they are fairly new. Calico has a way richer set of rules and what it can do. If you looking into just using everything standard, you can definitely take a look into Azure network policies and see if that satisfies your needs. I would say that simplification of your Kubernetes cluster, I would go for that in any given setup, just because the platform itself is pretty complex. And if you start assembling a la carte menu from all the different vendors of specific implementation, you can easily get yourself into some kind of spaghetti situation where there is a bunch of products and you need tons of people to maintain all of that. So if you can solve your problem with Azure network policies, go for it. Okay, so I'm going to jump into, let's see what I got in here. Did I just close the window that I needed? Oh, looks like it. Okay. Okay, so here I have my Kubernetes cluster, so I can get the nodes. Hopefully you can see the, let me know if the font is too small and I can increase it. I try to make it a little bit bigger so that it's going to be comfortable. So here's my Kubernetes cluster that has 3 nodes. By just looking at the naming notation for the nodes, you can probably guess that's currently running in AWS. I'm running this cluster built with kube8am, so it's not a managed solution like a EKS. So the setup, I'm basically leveraging the infrastructure of AWS to run my Kubernetes cluster. These scenarios that I want to go are going to be from the repo right here, the link I posted in the chat. And this repo, I will try to add a little bit more demo scenarios for here to into this repo to cover everything that we are going to talk about in the session. So for the demos, I use 2 apps in here. And actually, before I run that, let me see. Here are my 2 demos. two applications, and if I take a look or show you the YAML, there is a namespace definition for each. There is an S1 and S2, and then each stack has Nginx deployment, and there is a pod. In one, there is a CentOS pod, and the other one, there is a NetShoot pod. Those are not significant for this. Those are just utility pods that I'm going to use to configure policies and then test access to various resources. So for the network policies, I was talking about the default deny and how to implement that. So let's start with implementing our default deny policy for one of the namespaces, and that's going to be KDS deny. Here is my default deny policy, which applies to my NS1 namespace. And you can see I'm defining here ingress, egress, but I'm not providing any rules for those, which means the traffic is going to be dropped as soon as I deploy it. And just to show you that that's going to be the case, I'm going to execute these two commands. So that's running the curling the Nginx from my CentOS pod in S1, and you can see right here. And both of these commands are failing right now, which I believe I probably forgot to clean something. I was just cleaning the cluster right before the session, so probably I have some stuff lingering around. Yes, I do. And I'm not going to spend time on the UI. What you're seeing right now, that's a Calico Enterprise dashboards, because just going through all the UI will take some time. I'll walk through some of the screens that I'm going to show, but for details or details on Calico Enterprise, you can go to our YouTube channel and find a session that goes into dives into Calico Enterprise features and capabilities. Okay, let's take a look what I have deployed. I have my namespaces, NS1 and NS2. Okay, I have in NS1, I have my pods deployed. In NS2, I have my pods deployed. So now the ping should be happening. Yes, so looks like it just took a few moments to deploy that. So you can see I can get from both of the utility pods, CentOS and NetShoot, to the Nginx service that is running in respective namespace. So now I'm going to implement my default deny policy, which for the NS1 namespace, which is supposed to block the access. So now if I run the ping, now the ping is going to fail. Okay. So next step that I want to do is to make sure when you implement default deny, you're effectively blocking all the egress/ingress traffic within either namespace, or if it's a global Calico global network policy within the cluster. One thing that I need to do right now is to make sure that my pods can do DNS query lookups. So I'm going to deploy kubedns policy to allow traffic, and here's the policy itself for kubedns. It's right here. So I'm using global network policy, Calico network policy, and applying that to all the workloads in my cluster and allowing the egress over port 53. So let's do this. Done. And the next thing that I want to do, since I blocked all ingress and egress, I need to allow ingress into my Nginx pod so that CentOS, my CentOS pod within the NS1 namespace can get into it. And here's the policy for that one. But, let's ingress this one. So in here, you can see I'm defining the, this is namespace scoped policy. I'm using pod selector to match my Nginx label, and on the ingress rule, I'm saying that I'm allowing access from anything within the namespace with this label, and that was my default, or my namespace, and NS1 has this label, compliance open. Okay. So now, if I test my access, now I can get to my Nginx service from CentOS. So if I deploy anything else within this namespace, I will be able to get to the Nginx, to curl Nginx service, but any other communications would not be allowed to either to workloads in the namespace or outside, except for egress over port 53 for the DNS lookups. And similar stuff I can do with Calico policy. So I can implement Calico deny all, because right now, if you remember my second namespace in S2, it's still allowing traffic, even though I did not apply any policies to it. So what I'm going to do is to deploy this Calico deny all, which is going to be a global network policy, and it it deploys within order 2000. And the reason I put in there 2000 because I want to make sure that if you remember, I said default denies acts as a catch-all. So you need to make sure that your default deny is the last policy that gets applied or gets evaluated, because as soon as the match happens and there is a drop or deny for the flow, no further rules are going to be processed. So that's why you need to make sure that your default deny policies are implemented and evaluated as last policies. So in here, you can see a few examples. So there is an order that's what sets it apart from Kubernetes network policies. And also selector allows you to create quite sophisticated conditions in here for the rules of where to apply it. So in my case, I'm saying apply this only to NS1 and S2 namespaces. And I'm using this Project Calico org/namespace. That's a label that gets set up by Calico automatically on the namespaces. So you won't see it if you just curl it, but you will see it in Calico enterprise tools like the manager UI. So let me deploy this. And now this, okay, so now you can see that the second one, the NS2 namespace now does not allow the NetShoot pod to get to the Nginx service within that namespace. And to allow that, I will just deploy another Calico, a few Calico policies in here. And before I do that, let's take a look into that. So here's Calico allow policy. So you can see the order is higher, which means it's going to be evaluated before my default deny. And if traffic is allowed, it's going to go through. So it's not going to trickle down to all the way to the default deny. Okay, so now both of my namespaces have similar setup achieved through Kubernetes network policy and Calico network policy. And before I jump to the next section, I want to briefly touch upon this log action, which I mentioned. Calico provides additional actions for the rules. So one of those you saw, for instance, in here in the kubedns, I'm using allow and I'm using pass. Pass, typically you use that with Calico Enterprise where we have tiers, and I'll get to those in a moment. And another, there is allow deny, which are standard concepts, and then there is pass, and there is a log. So the log one, here's an example of the login of the log action. And what I'm doing in here, I just want to capture the flow. I want to log the access for a specific flow. And so this functionality, the login, can be very useful in open source products of Calico or the project Calico, because you do not have the flow logs, which Calico Enterprise by default sets up and provides you access to. So if you still want to get some information and want to be able to track what's happening, that's one of the ways how you can do that. You can set up a login action and then scrape that information from Linux kernel log access. So before I do that, I want to here is one of the nodes where I have my workloads running. So let me show you that. Here's the node IP basically in its name, and you can see my Nginx pods are running on that node. That's one of the workers. Here's the same IP. So I have a tail command in here to tail the kern log, which captures the access. And right now, each of my pods is pinging the Nginx service within its namespace, each of my utility pods, and every 3 seconds. So what's going to happen if I deploy this log policy? So now you can see my kern log. There are Calico drops in here, which showing you that the traffic is going from this IP to this IP, and you can match those to the IPs of your pods in here. Here's my 30, here's my 57. So you using the log action, you can actually gather information, the access information, and then scrape that and put into like maybe some SIEM tool that you're using. Okay, so the next step, I want to create a few service accounts, which I will use to configure the access. Will configure the access to what users can do within the cluster, which effectively allows you to create different groups or different teams to provide different level of access to your, to manage policies, to manage objects within your cluster that Calico provides you access to. And where this is going to be useful in one of the examples when I get, I think in next or the following example, where I get to the tiers, where you can create those and then provide access to different users. I already created a user admin user. Here's the service account Paul, which gives you full access. And the reason I created that because I needed access to Calico Enterprise Manager UI, and that's how I'm logging into it. So if I take a look into my service accounts in default namespace, my user is called Jane, a little bit different, but the same configuration for it. So I'm going just to create this user Sally. And the role bindings for that user. And the reason, actually, it's probably better to show why. Okay, so here's a new session. Did I create the user? Yes, I did. Okay. And let me get the user token. Here's the command for this. And so you can see as I log in, and if I don't have the right role set up, you will get a bunch of these pop-ups saying that you do not have right level of access, and a bunch of screens are empty. Because you need to configure a certain roles and the permissions to get access to these objects. As I mentioned before, we in Calico we use Kubernetes RBAC to access everything that Calico gives you access to. So for that, in order to do that, let me deploy roles and role bindings for my Sally user. And now I should be able to get my screens. Yeah, okay. So now you can see that I can browse around. One difference you'll see, though, that in here I have, I can see security tier, I can see default tier. So what you see in the policies board in Calico Enterprise Manager, the representation is tiers and policies within those tiers. So if you imagine the traffic coming from left to right, it will enter the far left tier first. That's going to be the first tier that is going to evaluate the policies against the incoming traffic or egress as well. And then it will go through the policies in that tier top down, and then only then, if none of the policies applied for that flow, will go to the next tier and so forth, all the way until default. So in Calico open source, you have only default tier. You don't have capability of creating different other tiers. In Calico Enterprise, that's where you gain this ability to create tiers, which allows you probably one of the common uses of that is to use the organizational structure and team functions to map those tiers to team functions, and then allow those teams to manage all the stuff that they allow to use. And here's an example of the same view with a full admin user. So you can see I have allowed Tigera tier in here, security and default, and I can see all of them, and I can manage all of them. But for my Sally user, I can see only 2 of those. Two screens. Okay, so the next concept is managing sets of, to manage access to a group of IPs or maybe domain names. And so in Calico, there is a concept of network sets and global network sets, which you can use to group either CIDRs or rangers, subnets, entire subnets, or just individual IP addresses, which represent CIDR representation that's going to be a subnet of one. And you can use also domains for when using DNS network policies. which is an attribute of Calico Enterprise. So you can use the domain names to create network sets as well. What that allows you to do is to, instead of going and defining those on each policy, you can create a group and target that group and manage that independently. For instance, you have a team which you granted access to manage network sets, like security team, and they are managing those IPs or domain names which should be allowed access or should not be allowed access to, and that's the resource that can be used for that. So in my example, I'm deploying a network set called public nets. And before I do that, let me show it to you. So the public nets, I'm just defining a bunch of public networks, /8, 1 through like 200 something. One thing to note in here, there is a label type public. That's what that's what will be used to target it. In Calico, everything that can be targeted within network policies needs to have a label. So this label, just pay attention to that. So I'm deploying my network set. And before I deploy the egress rule, let's take a look at this. I have created an example, like grabbing just the IP address for apple.com and then running a ping against that. So you can see I can ping that resource. So now let's apply the policy and try that again. So now I cannot do that. And the reason for that is that my IP in here falls within one of those ranges. Okay, it's 23 subnet, which is one of the subnets in my network set. Somewhere here, 23. It's right here. So in that way, you can target, you can create kind of like this fences around what should not be allowed to be accessed. There is, in Calico Enterprise, there is additional resource that can be used for that. It's called thread feeds, which effectively allows you to configure just the URL to fetch a list of some IP addresses or networks or domain names. And then it gets converted, whatever it fetches, it gets converted into the network set, and then you can target that. And since it's maintained somewhere outside, so outside of Calico completely, then it gives you that flexibility of using the current tools, the systems that you're using for that, and Calico just can consume that. Okay, so did I apply my egress? No, I didn't. So now let's apply the egress rule and try my ping one more time. Oh, I already applied the egress rule. That was the whole purpose right here. Yeah. Okay. Kind of got lost where I wanted to go. And I want to show you, for instance, that let's try the to curl Google, and we also cannot get there. So effectively, the access to any subnet, any network that is in my network set right now is blocked because I'm explicitly blocking it. And let me show you this. So here's what I'm doing here. I'm saying allow access to kubedns, and if I created the my kubedns access as a global network policy in upper tier that would apply to everything, I won't need to do that in other policies. But in my case, example where I created the kubedns access was in default tier, which is lower than security tier. And since I'm defining the flow here, I'm opening that, and I'm defining two rules in here: allow access to anything that is not listed within the public, and deny everything within the public. So that allows me to still maintain the access to my Nginx, for instance, which I actually didn't show in. Yeah, so my center spot can still go to Nginx service within the cluster, but it cannot get outside. Here's getting to the policy tiers. I already described the policy tiers, and I actually already deployed this, so I'm going to skip it right now and just move to the next one. There is, as I mentioned, there is ability to create DNS policy. So within DNS, that's where you can say, I would allow access to a specific domain. So since I already have my network set, which is blocking access to all the public IPs or public networks, which are defined right here, and paying attention to the order, it's 100. Get into my DNS policy, you'll see that I'm defining order 90, which means the lower the number, the higher in the tier that policy is, which means it's going to be evaluated before the something ordered with a higher number. So in here, you can see I'm defining this policy before the policy that does the drop. And then I'm saying allow access to the domains. And I'm listing here Google and star Google because I will use www.google.com to curl it. And before I do that, I actually did already. So you can see if I try to curl it, I cannot do that. And now let's deploy the policy and try it again. Now I can. And just to confirm that our policy is working correctly, I'll try some other domain, which I did not explicitly allow access to, and I cannot do that. So I can only get access to whatever I defined. And last demo that I wanted to show is global alerts. That's another capability of Calico Enterprise where you can alert the team of a malicious activity or something is happening that is not authorized or was not anticipated. In my case, I created a simple alert that watches the global network sets, and if there is a change to that, then it's going to generate an alert. So what I'm going to do is to deploy the alert and generate a change to my public netset YAML, right? So if I go into Calico Enterprise and take a look into the network sets, so the screen, there is a screen for the network set right here. Here's my public nets, and you can see it starts with 1.0, then 2.0, and so forth. So now I'm going to just run a command and yeah, watch for, if you're running that on your machine, make sure that your set is using correct parameters, because on Mac, parameters for set differ. So now I updated it. You can see my 1.0.0 is gone from there. And so if I jump to the alerts in here, well, this is previous alert, but in a minute or so, the next alert is going to be generated and it's going to look like this. Let's see if it was not yet. And it shows you, so for my alert, just to showcase it, I set the count to 0. Basically, any change would trigger it. If you can specify different number of a threshold that will trigger an alert just to capture something, you know, like there is a SWIP and that's trying to change a bunch of global network sets. Okay, that's it for demos right now. I will add more demos to the repository, and we are running out of time right now. Let me go through the questions just to see if anyone has a question. If you have a few more minutes to spare, stay around. I have a few more things to talk about that I want to finish from the slides. If you don't, please post your question and I'll try to answer it right now before I go into the. There is a comment when I guess when I was showing the login function, there's a comment saying it's more like NSG, Network Security Group, where logs will be stored. Yeah, the login action is similar, but NSG, for instance, it's all easily pluggable with cloud providers. Here, it's a little bit more involved. You'll have to make sure that you have some mechanism to scrape that information. Okay, I didn't see new questions yet, so what I'm going to do is to go through the rest of the topics in here. So for security controls in Calico, you get network policies, global network policies, network sets, and global network sets. We looked into those. We looked into tiers. Threat feeds, I mentioned those. They effectively, once you deploy them, they will be converted into network set. They will be converted into global network set. Therefore, they're called global threat feeds. And the definition itself, you can get it using kubectl, but the result of that definition is going to be a global network set. And global alerts, that's what we deployed. And there are reporting capabilities in Calico as well. And there is one more bullet point that I missed in here. That's the threat detection capabilities, intrusion detection, anomaly detection. So that's an example of global alert. They act or they use flow logs, audit logs, and DNS logs. You can create those alerts, and let me show you actually how that would look. Oh, it's a wrong screen. So in here, if I get into the alerts, you will see, for instance, there are templates in here, and there is an alert. This is my alert that I created. And you can see there is a query in here and some additional parameters, some additional fields to configure that alert. So you can create those as usual, as regular Kubernetes resource. So it's all YAML, defined in YAML. The compliance reporting, which allows you to create reports to get a snapshot of your system, like a particular namespace. How many policies are in the namespace? How many endpoints? How many policies covering those? So that allows you to basically get your security posture at any given time, and you can run those on scheduled basis. They are configured. They have the cron job schedule that can be used to define how often you want to run those. And the last thing, I think it's the last thing, yeah, I wanted to talk about is the intrusion detection, anomaly detection, and threat defense. Right now, there are no demos for this, but that's something I will be adding to the repo. So you can check that from time to time. And the main capabilities that these features or this functionality can address, that's block known bad actors. So one example of those, for instance, we saw today using the network set. To identify malicious activity, anything that's anomalous happen or I guess someone trying to access something and not having access, not being able to, you can flag that. Anomaly detection, that's we using machine learning capabilities we have. Since we capture in the flow logs, we have the tasks that you can trigger, and they will be running continuously, kind of consuming those flow logs and trying to look for patterns for some anomalies in there. Once anomaly happens, then you will get an alert. Mod for critical workloads. So what that essentially means that you can create policies and use the tools to fence off a critical workloads where the alerting can be quite high just because of the sensitivity, but not necessarily for the entire cluster. Then there is honeypots capability, which was recently added to Calico, that allows to run processes that look and act as legitimate, let's say MySQL pod, because it will run MySQL in it, but it would not have any database or would not be connected to any production database. What we use it for is to get someone who's trying to penetrate the cluster, trying to get into your database, and as soon as they hit that, we will flag. We will generate alert. We will generate an alert, and we will. You can configure the CI/CD to act as an addition to that to take an action. And automated mitigation. That's what I'm saying. As you can plug it in, chain it with the CI/CD tooling that you have to automatically take an action upon the anomaly being detected or something malicious is happening. And so the last thing is key takeaways from what we discussed today. It's Kubernetes network policies. They are provided in declarative manner to define security for Kubernetes cluster, for Kubernetes workloads. Calico network policies are built, extend the kind of like a superset of Kubernetes network policies, which provide additional capabilities like ordering, global scope, additional, for instance, you can target the service accounts within the policy, so fine-grained and coarse-grained rules. The network policy is quite scalable. The implementation is quite scalable. We have additional configuration guidance how you can, if you're running a cluster with tens of thousands of nodes, how you can mitigate the impact from network policy enforcement, where Calico node, that's one of the components in the architecture, pulls the policies from the control plane. When you get to like a few hundred nodes in the cluster, then you can use another component called Calico Taifa that allows you to that acts like an edge cache. It goes to control plane, pulls the policies whenever there is a change, and caches those. So then you create your nodes, groups of nodes talking to the Taifa component instead of going to the control plane. That allows you to scale the cluster to tens of thousands of nodes. Alerting functionality that we saw an example, reporting capabilities for compliance reports, intrusion detection, defense, and the threat defense capabilities. So that's pretty much it for this session. Just to quickly go through a few sessions that we are planning for the rest of the month. Here's sessions that you can sign up for. And you can get a trial of, if you're interested to check out the Calico Enterprise capabilities, you can get a trial from Tigera.io/trial. The Calico will be set up for you and configure it. All you will get is the endpoint that and kubectl that you can just locally fetch it and locally use with your kubectl to interact with the cluster, and you'll get the access also to the UI. So you can click around if you're interested and check out and test test the capabilities. Also, I believe the trial provided with guided labs where they walk you through the scenarios, how to configure those. Okay, that's the last thing I wanted to mention. If you have any questions, please post them in the chat. Okay. So there is one question. L5 to L7 is possible with upstream version or enterprise license. So the L5 to L7, I believe that's enterprise capability, but I'll have to check. So there is another question. What is the tier and where do you apply it to namespace? So the tiers are outside of the namespaces. They do not necessarily belong to any of those. It's just a construct that allows you to stack your policies into. And each tier also has that ordering. So if I expand my security tier, right? So you can see it doesn't, it lives outside of any namespace. It's just a resource in Kubernetes. It has an order which allows the tier to be stacked. If you look into the policy board, you can see, for instance, and right now I'm not showing that, but what I can do, I can toggle the order right here, and you'll see some additional information. Actually, like I can show you, there's a bunch of information that can be in this screen where you can see all the connections. It gets quite busy in here. So, for instance, that's typically what I do. It allows me to see the tier, the order number. It allows me to see how many endpoints a specific policy applies to. For instance, you can see kubedns, since I believe it had the selector all, which means I have 29 endpoints in my cluster that this policy is gets applied to. And for L5 to L7, so the component that is used for the integration is called Dicastis. And that component itself, I believe it's open source, but the full integration, like out of the box integration, comes with Calico Enterprise. So you can technically you can find the Dicastis on GitHub. And you can try to connect it to Envoy. I haven't done that, so cannot really say whether that would work. But I would encourage you to go to Calico users Slack and ask that question in there. You'll probably get the answer quicker than I'll be able to find it. Okay, I don't see any other questions coming in. So thank you very much for attending this session. And hope to see you in next sessions. Have a good one. Bye-bye.